Good day, one and all. So last time we did our entity manager, we had 5 Marios spinning around. Wee! All good. Whoa, whoa. So there we go. So those are our 5 Mario entities spinning around. Today we're going to talk about two things: indices, as well as the design pattern Singleton. So first thing, let's talk about indices. What indices are is they allow for quick access. Before we made this get entity thing, we don't really actually need it as much because we have another way. We have what's known as an indice, and how an indice works is it's basically like this. This here is called an indice. It's basically calling the object entity list and finding anything with the I in it. So what we're going to do is we're going to create the indice. It's going to be public. It's basically the same thing as a property. So we give it the access modifier, what it's returning, and we're going to say this, as in this object. And it is going to be, first of all, the first one is going to be by the int ID. So whatever we pass in is going to return. It's going to actually find the list object, get and set. So the get is going to actually loop through. Let's see, list dot find. Yeah, unfortunately, that's not what it's. Yeah, it's using the ID won't necessarily always be the same, so we have to actually do our own. There is no functionality for it, so yet again we'll create a for loop. So starting off with the indice or the counter, 0, condition I less than what is it? I less than entity. Sorry, I'm having a brain fart. Count I plus plus. We're going to loop through the entire list, and then if entity list at I dot ID is equal to ID, we don't want to set it. If they are equal, return entity list.i. Else we are going to return null because we never found it. There we go. Cool, eh? Then we pretty much can copy and paste this. And it's the same thing, the only difference is we're going to set this point to value. So this is going to come in, it's going to find the ID in this, it's going to find the object in the list that is equal to the object ID, the object's ID. If it's found, it's either going to return it or set it. If it can't find it in the get, it's going to return null. Now that's not the only way. You can also do a second one. It's going to be public game entity this. We're going to pass in a string. That's right, you can use a string to find it, and we're going to find it by the name. So we're going to do get and set. It's going to be the same sort of for loop, so we'll just take the for loop. We're going to paste that in there. If entity list at I dot name is equal, oops, too many equals. Make sure I put the double equals to the passed in name, then return entity list dot I. we're going to return that. Otherwise, return null. Same thing, exact same code. The only difference is we're checking with the name, which is a string, instead of the ID. So you understand why we have the base game entities, name, and ID. It's so we can actually find the stuff. And that I did that wrong. Oh, crap, stop doing that. And if you hit Shift Tab, it actually does backwards indentation. And then we're going to do if, same thing, entity list I equals, oops, not I, dot name equals name. Like I said, you don't need these brackets half the time. You can do cascading ifs, but those piss people off. Or cascading little, I'll show you in a sec. We're going to set entity list I equals value. You could actually do this. This is perfectly valid as well, but that will piss people off because you can have ifs instead of ifs. Yeah, I've pissed off a few people doing that myself. Creating like cascading ifs and else without any brackets or anything. So it goes if, else, if, for, if, and it's all just like one line statements. It's kind of weird. They can piss people off. So there we go. So now we can either find it by the ID or by the name. So we'll save that and we'll go back to our game here. So now what we're going to do is after we've loaded the content, load content, I'm going to want to find, say, manager, and I'm going to pass in the name Mario. They all have Mario. Well, actually, since they all have Mario, let's do Mario plus I. So this will now append a number value to the end of each Mario. Mar03 dot, we're going to change its scale. I'm going to say it's sprite dot scale, and we're going to set its scale to be let's make it 1.1. So its scale is going to be 1.1 to start off with. It's 1.1f. And then we're going to do manager. No, not marshlands. Manager. Orientate ID 1. Yeah, ID 1. Dot sprite. Or no, dot. Yeah, dot sprite dot origin. No, dot origin, thank you, equals new vector 2. Now this is, remember I had that little screw up last episode, this is where we can do the manager dot 1 dot texture dot width divided by 2. And manager, make sure you're using the same ID. Oops. 1 dot texture dot height divided by 2. So now we're going to see one that's origin is going to be spinning differently, hopefully, if this all works out. Oh my god. So notice one is properly spinning in place and the other one is twice the size. So we access those specific ones by using the name and ID. Whereas the actual get function will only get it if it's the exact same ID. Since you can have multiple Mario causes. Like if I say change just this to Mario, Well, this will blow up because you should put a check to see that it's null. Because this is actually going to put a null exception because this returns a null if we can't find it. So you would have to actually put in a check to make sure that this exists and set it to a temporary variable. Check for null and then do all this, but I'm just too lazy at this point to do it. Whoops, no, I want to stop it. If I change that to Mario and just took this out, and now they're all named Mario, you'll notice that it now sets the first one just to do the scaling and spinning. But I don't want to do that. There, Mario 3. So there, we have them all doing different things. Alright, well, not quite different things, but for the most part, one's big and one's properly rotating among the origin. So that's how indices work. Pretty cool, eh? There's all our indice code once again. Pretty much the same thing. And like I said, our get does just an overall finding. This object has to be the exact same as this object, meaning the name and ID have to match. So there we go. Now I'm going to try an experiment here quickly. Where's my manager? Manager? Manager. Manager. Here he is. I think I can also have public this. No, wait. Public game entity this ID. Oops. Get set. I don't know if this will actually work. I don't think so. Don't know if this is gonna work. Yeah, I do. Oh. Does that actually do it? Oh my god, that actually works. I didn't think that this would actually work. I didn't think you can tell it using the this keyword, but apparently it does work. So wow, I learned something new. Public, abstract. So now anything that extends from game entity, anything that inherits from game entity, or sorry, that inherits from manager, is going to have to implement these. So that's my little experiment for the day that I completely didn't know you could actually do. Cool. Oh my god, that is really awesome. I'm ecstatic right now. No, not really. But yeah, there we go. So that's the first little bit. Our second bit is now Singleton. So we want to force a Singleton design pattern onto this. All managers are required to have a Singleton, so now that I found out, well actually no, I knew you could do this. Abstract, get instance, oops, sorry. We're going to return of type manager. And we are going to have a, I don't know if this will work, but we're going to have a protected static type manager called instance. We'll just call it instance. Actually, I don't want it to be abstract, sorry. Abstract instance. I want it to be virtual case they decide to override it. No, I don't want them to override it. Yeah, this is one of the things. You have to decide what you want people to do. I don't want it to be overridden. Instance, and it's only going to have a get. So I don't know if this will work. So what we have here is we have, it should be private, because I don't want anybody to have access to the instance. Alright. And now we're gonna have we're gonna create ourselves a public default constructor. And so this is the design pattern of a singleton. We have a private static instance. The idea of a singleton is to only have one instance of the class at all time. So how do we do that? First of all, we don't want anybody to create an instance of manager, so we make it private. So now no one can access the constructor. Then we have a private, obviously, instance of a manager class, which is this instance, and then we only have an accessor which only gets, because we don't want people to be able to set it. So how do we get only one instance? We'll check if instance is equal to null, create it. So now instance equals new manager. I can't create one, unfortunately. Yeah, so I'm gonna have to make this abstract. So let's take this out. We'll just make this abstract. Make that abstract. We're gonna make that. We don't need that. So let's see what we got here. We still no. What is our complaint? Probably have to implement. So we have to implement. So we're gonna want to make this now protected. This is kind of a weird way of doing it, but I showed you the basic way of doing it. Now we're going to do it through inheritance. So now what we're going to have to do is we're going to have to override, public override instance. I'll put that down there. We're going to want to make our constructor private. Do I have, where's my constructor? I want to make this private. And because we have nothing in game entity, so there's no reason to have a constructor, and it's just going to call the default one anyways on us, so we don't have to worry about that. Put that down and I'll be able to see better. So what we're going to do is if instance, which is protected, so we do have access to it, if instance equals null, then create instance equals oh, but I don't know if this will work. It's all these little things that are. We have to make it static, because remember, static belongs to the class. Oops. Entities. So I might be leading you down the path of destruction here, but we'll find out. And then we're going to just want to return Oops. Come on. New instance. Alright, how many complaints do we have now? Yeah, unfortunately, if it's static, I can't override it. So I thought that would be a pretty nifty thing to do, but no, I can't do this. I have to take that out. But I'm still going to keep the instance public. So this way, everything that inherits has an instance. So now that we made this private, we can't actually get an instance of manager anymore. So we'll delete that. So how do we get access to the singleton? Well, first, let's go back. What's going on here is basically what it's saying is that if instance, this instance here, which is a type manager, is equal to null, created inside this class using the private constructor. This constructor is private, so the only one that can use it is the person inside this class. We're going to create an instance of it, then return it. So that's only going to happen once, because the first time we do this, the instance is going to be null. The second time we do it, it's not going to be null anymore. It's going to actually equal this. And every other time we do it, it's going to equal the first time we did this. So it's only ever going to do once. And since the constructor is private, nobody outside of this class can create a new instance of manager. So manager is always going to be once. Since instance is static here, as well as this property is static, it basically means that we can only access it. Entity manager. We can now only, oh shit, it's actually got to be a manager. It's now got to be static as well, because remember, static belongs to the class. So now instead of calling, we don't need, we can take this out completely, so we don't need that anymore. How we call it is by calling the class. Entity manager. And then we have to call the static instance, which then calls the actual instance that allows us to access itself. So basically, yeah, it's a little bit more typing and more, a little bit more typing, but it allows, like I said, it makes it so that there's only one instance, and you only want one instance of your managers, because you don't want somebody creating a new list of managers or a new list of entities in your game that aren't going to be drawn. That's just silly, right? You always want this main one to be drawn. So there we go. There we got Mario scaling. Notice, yeah, that one scales finally. Now they're all big. Now it's going to screw up his. But there we go. So that's all indices and Singleton. Remember, indices, it's the access modifier, the return type, the keyword this instance, and then what you're checking. In this case, ID or string. You can count with other things. You can actually check with objects as well. So indices are really powerful, and they're excellent for getting and setting. You can actually also just do, like if I go back to our manager, no, game, where I'm adding, I don't even have to say add Mario, I can just say I equals Mario. Oh, that was a null problem exception. So we'll change that back. I'm sure there's a small little issue that I have to fix that I didn't actually look up, but you can do stuff like that. No, stop. Why are you complaining now? Oh no, because I'm actually adding. I want to just add the entity. Sorry, I still have to do it like that. I have to do in the eye actually selects a specific entity. But anyways, that's indices. And singletons, like I said, creates a single instance by creating a private or a protected instance that's static, the return type, which is the name of the class, and called instance, and then that's protected or private, meaning no one else can access it outside. Then you make your constructor of that object you want to make singleton private, and then you create a public static instance property that returns the class type. In this case it's manager, but since entity manager inherits from manager, it basically it means the same thing. So what you do is you only have a read only, which is a get, checking if the instance is null, and that's going to happen only the first time you do it. So right now it's actually the first time it's doing it is right here. If we actually put a breakpoint and we go in, we put a breakpoint there, and we'll put a breakpoint there, and we'll hit F5. That was F6, F5. So if we head in and we step into, no, it didn't step into it. Dang. If you actually do it, what will happen is it will actually step into this property up here, and it will be null this first time. It will create the instance to a new game manager or entity manager, and then return that instance. And then the second time it comes in, it will not be null, so it's just going to simply return the same instance over and over again throughout the entire history of the game. So that's how a singleton works. No, don't run breakpoints. Just run. Don't run breakpoints. Just run. So there's our Mario. There's singletons and indices. If you have any questions, let me know. Singletons could be a little hard to get your head around, but yeah. Thank you for watching, and there Mario goes. Bye now.